Hello, everyone. Welcome to the QA2 Excel learning video again. And today, it should be our last Excel learning video. Okay, so what is this about? The last video, we'll talk about how to use Excel to run the multiple regression analysis. So I would like to use the chapter 4, part 2, the example 2 as the illustration. Okay. Suppose, actually, we already talked about the example 1 in class. Okay, so this is about whether the working experience and the aptitude test score of the programmers will affect their salary or not. So now in the example 2, this is about adding a new independent variable, degree. Okay, that is whether the programmers got the graduate degrees or not. In the multiple regression model, whether it will improve the predictions of their salaries or not. Okay, so now let me share the Word file for you. Okay, so wait a minute, let me share the, okay, so I have to open the file first. Sorry about that. Give me a second. Okay. Okay, it should be this one, and this one, and this one. Okay, so wait a minute. Let me go to the share screen first. Okay, share. Yes, this one. Okay, now you see this screen. Okay, so suppose we already talked about the example 1 in class. So I would like to skip it. Okay, and just take a look at the example 2. We didn't have time to talk about the example 2. Actually, it is refer to the example 1, and we add one more independent variable, which is degree. Okay, in our regression model, and this variable, it is the categorical variable, if you can look at it. Okay, yes, no, yes, no. So that means whether the programmer has the bachelor degree, okay, or not. No, that means no. And yes, he or she obtained the bachelor degree. Okay, so therefore, if we have to input, okay, or want Excel to run the multiple regression analysis for us. Okay, so for the for the X3, maybe we can call, you can see here X3. This is for the degree, okay, for the variable degree, and we can't just input the wording, okay, in the Excel. They cannot be run, right? So therefore, we have to just change it to numbers. Okay, so usually, or here in our presentation, 0 represents the individuals or the programmer does not have the graduate degree, and number 1, that means the individual have the graduate degree. Okay, so remember, if the regression model contain more than one X variable, okay, we cannot use just calculator, okay, to find the intercept, to find the sample intercept and the sample slope. We must use the Excel, okay, to run the multiple regression analysis for us, or use some other statistical software like the SPSS or the SAS, something like that. Okay, so therefore, now here, this is the population regression model. Okay, is also already given in the questions. Okay, and the form is something like this. Okay, y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon. So epsilon is the random error. It cannot be found. So usually we just need to consider the former part. Okay, this part. Okay, and the population regression line. If you remember, the fact is it cannot be found as well. Let me see whether, okay. cannot be found. Okay, so yeah, because the data set, the population data set is supposed to be very large. Okay, we cannot investigate every members in the populations. So therefore, what we can do is based on the sample data set. Now let's underline some key points. The sample, okay, here the data contain 20 programmers' informations, their salaries, their whether they have the degree, and the aptitude test score and the working experience. Okay, so how can we run such kind of Excel the regression output? Okay, and then to help us to answer the questions, okay, or to help us to know, okay, actually based on the regression, the Excel output, we can just know based on the ANOVA, the results or the table, we can know whether the whole model is significant or not. Okay, and based on the last table here, the t-test and the p-value, we can just know each individual, okay, the X variable is significant in the regression model or not. Okay, however, in the final examinations or in the assignment, I would hide some of the parts here, okay, so that you can only use what you are given in the Excel output and then to do the questions, okay? So yeah, here in this video, I will demonstrate how to run the full, okay, the Excel, the regression analysis, okay, in the Excel, okay? So therefore, yeah, for the hand calculations, okay, so actually you can refer to the hand calculations in the class, okay, or in this file already. Okay, I showed you the hand the calculation, the given the Excel regression output. Okay, so now let's okay. Before, okay, if we want to run the Excel, okay, to run the regression analysis, we have to first input the data set into the Excel first. So let me share the, yeah, the Excel file with you. Okay, so suppose I already input the data set, okay, here, and so I would like to let you know, okay, the first three of them are the X variable, X1, X2, and X3. And then the last column, this is the salary, which is the variable Y, the dependent variable. Okay, so the X variable should be put together, okay, because later on, when we do the data highlights, okay, so we have to highlight the X variable all together, okay, so in a range. So now let's go to the data and then go to the top right hand corner, click the data analysis button, and then go to the regression. Okay, and then the input, the first one is the input the Y data range. So we can just highlight the Y data range, the data set here, and then input the X data range. So we have to input these three, okay, all together. All these three columns are the X variables. And don't forget to to click the labels so that the first row, okay, they are the labels, okay. And then we can also click, okay, it's up to you. For the last one, normal probability plot, okay, it can help us to check whether the residuals, that is the error terms, or that is the epsilon, the random error, the error terms, follow normal distributions or not, okay, or fulfill such kind of assumption in the regression. And we can also plot the residual plot, okay, to see whether the residuals, okay, the residual plot is the error versus the X, okay, the variable X, and also the line fit plots. Okay, so because there are more than one X variable, so the line fit plots, okay, is each, yeah, the X variable, okay, together with the predicted, okay, the X the values as well. So maybe I just click these two and then the output range. So let's click the blank cell here. Okay. So maybe I would like to click here and then click OK. Okay, so now let me enlarge it. Okay, now you can see several plots are provided. So the normal probability plot. So if you look at the lecture notes, it's mentioned that if the normal probability plot is the increasing trend, the straight line, this is good. Okay, and then it represents the error terms follow the normal distribution, such kind of assumption, okay, in the regression analysis. And then the residual plot, you can see is the residual plot for each X variable, for X1, X2, and the X3, the variable. Okay, remember, no pattern is good. Okay, so all the points or the dots are scattered around the horizontal, the zero line is good. So experience X1, the residual plot is good. And yeah, for the degree, okay, why this is the vertical straight line like this? Because it's either 0 or 1, okay, the outcome. All right, and for the X2, okay, the aptitude test score, the dogs, okay, like to scatter, okay, between the 60 and 100, okay, something like that. So maybe if we just enlarge the scale, okay, it will be scattered around maybe, okay, something like that. So okay, so here is the regression output. Okay, so remember, actually, to see whether the regression model is significant or not, remember we should look at the ANOVA, the output, isn't it? Okay, so from the ANOVA, this one, the F, this is the F, the test statistics, isn't it? Okay, and yeah, and here, this is the p-value. Okay, this is the p-value. So based on the p-value, okay, yeah, let me just type it, check, okay, whether the whole model or the overall model is significant or not. Okay, so let me highlight. Okay, maybe using this color. Okay, now the p-value. Okay, we can locate the answer very quickly. So this is the p-value, isn't it? Okay, now the p-value 9.416, okay, or 417 times 10 to the power negative 0.7. Okay, so very, very small, near 0. Okay, so p-value, okay, by the p-value approach, okay, so yeah, based on the okay, maybe since p-value is equal to 0, so which is less than the alpha ANOVA, okay, the alpha, maybe in the example 2, is this the 0.05? Just suppose 0.05. Okay, so, okay, we can check it. Okay, wait a minute. Let me check it, the Word file, see whether the whole model significant. Okay. Okay, then the part B, okay, yes, is to test the whole model significant, okay, at the alpha equal to 0.05. So if we already run the Excel output by the ANOVA, the p-value, okay, so we can know the answer very quickly, okay. However, in the exam, okay, or in the Excel output that I give you by hide some of the parts, okay, so you cannot look at, you cannot find the p-value, right? So therefore, you can only find the or you can only use the test statistics, the critical value approach to do so. Okay, so therefore, remember the population regression line. Okay, so this is the population regression line to test the whole model significant. So that means is to test whether the beta 1, beta 2, and the beta 3 is equal to 0 or not. Okay, so if they are equal to 0, let me just highlight. Okay, if all of them are equal to 0, what will happen? Okay, then y will be equal to beta naught. Then that means this is just the horizontal straight line. And so therefore the x1, x2, and x3 do not have the relationship with the variable y. So therefore, yeah, to check the whole model significant, we have to check the population coefficients or the population slopes, okay, whether they are equal to 0 or not. Okay, so therefore you can see the H0, okay, beta 1 is equal to beta 2 is equal to beta 3 is equal to 0, and H1, okay, at least one beta, okay, is not equal to 0. Okay, so usually I will write down something like this, okay, or at least one beta is not 0. It's also okay, either one presentation. And then here, the test statistics. We have to use the critical value approach, okay, to do so. So the test statistics, F is equal to MSR over the MSE, okay, and MS the mean square regression over the mean square error. So it's further divided. Let me highlight the test statistic formula. You have to memorize the test statistic, the formula in the final exam, okay, by yourself. So in the regression, the ANOVA, okay, so MSR is further divided into SSR over the P, the degree of freedom, okay, and the MSE is further divided into SSE divided by N minus P minus 1. Let me highlight as well. What does this mean by the P? Do you remember? P stands for, okay, number of X variable. Now here in this example 2, we have 3 X variable. So here is 3, okay, and N is the total number of data in the data set. So it's 20 programmers. So it's 20 minus 3 minus 1. Number of X variable. Let me just write down variable. Okay. Okay, and now by the given the Excel output, here we can obtain the SS, isn't it? Okay, maybe highlight in yellow will be better. SS, okay, from the ANOVA, the table, we can obtain the SS, sum of square. Okay, so I will hide the MS, hide the F test statistic, hide the p-value so that you can find the test statistic by using the SS. The first one, SSR, isn't it? This is the SSR. Regression. Okay, and then residual, that is the error. So this is the second here. This is the SSE. SC, SC, E. SSE. Okay, so the last one is the SST, but we no need to use it. Okay, so based on these two values and also the degree of freedom, okay, so this is P and this is the n minus p minus 1. Okay, then we can, this value over this value over this value over this value, then we got the test statistics. Okay, and then the critical values. So remember, okay, go back. Okay, so if we use the, okay, critical value approach. So yeah, the first step is the draw the rejection region. First steps, second steps, right? And then this is the third steps, rejection region. So either write down the rejection rule or I simply draw the rejection region. So draw the right scalar distribution F, start from 0. Do you remember the rejection region for the N over F test is on the left-hand side or on the right-hand side? It's on the right-hand side. Okay, it's on the right-hand side. So we just cut the straight line on the right-hand side and then shade the area. And this is equal to alpha or alpha over 2, just one side. So it's just equal to alpha. Now alpha is equal to 0.05. Is given in the questions. How about the cutoff point? So the cutoff point, they are the CV, the critical values. So maybe use, okay, this color. This is F. Alpha 0.05. So the degree of freedom. The first one, numerator 3. Second one, denominator subloop. Okay, 20 minus 416. Okay, so we got is this one. We checked from the F table. We got this value, 3.24. Okay, and then we can know whether it's reject, whether the test statistics lies on the rejection regions or non-rejection region. Now it's 29 something. It's very very far away. Okay, so it should lies on the rejection region. 29 something. 786. 係啊，唔夠位啦。Okay, so we should reject the H naught. Reject H naught, that means the whole H1 is correct. That means the whole regression model is significant. Okay, so going back to our Excel, the p-value approach. Okay, the ANOVA. We got the ANOVA, the table. Let's go back to the, okay, the Excel. Okay, here, p-value, okay, is 0 to 0, which is less than the alpha equal to 0.05. So it's reject H naught. So that is the whole model is significant. Right, so let me also highlight these two sentences. What color? This color. Okay, so how about for the last table? Okay, it can help us to yeah, look at the t-test. Okay, the t-test test statistics. Okay, and the p-value here. It can help us to see whether individually, okay, each independent variable. So maybe I just added, this is the x1. Okay, and this is the variable x2. And this is the variable x3. So by the p-value, we can look at the, we no need to look at the p-value or do the hypothesis test on the intercept. Okay, just look at the individuals. Okay, the variable, the x variable, whether it will affects the variable y, or whether there is a linear relationship with the variable y individually. So just look at these three. Okay, let me highlight. Okay, so maybe yeah, if we just look at the yeah, these three values. Okay, the first one, x1 p-value 0.001. So just suppose the alpha also equal to 0.05. So less than 0.05, less than 0.05, reject H not reject H naught. So that means X1, X2 significant in the regression model. However, for the X3, you can see 0.26 something, which is larger than the alpha equal to 0.05. So do not reject H naught. So X3, okay, or the sample, the population coefficients or population slope should be equal to 0. The beta 3. So X3 is not significant. Okay, so therefore, yeah, if we have to rerun our model, okay, so actually, we should exclude, okay, the X3 and just include the X1, X2 in our regression model. Okay, okay, so just quickly go through the yeah, the Word file. So I already showed you done by hand, okay, the hand calculations in the Word file. So let's go back. Okay, let me go back. Let's just go back to the Word file. Okay, wait a minute. Okay, so let's look at the questions. Is now is to test the significance of the x1, x2, and the x3 individually, okay, or separately, whether they are significant in the regression model or not in the regression model at alpha equal to 0.05. So you can see in the solution, okay, we have to do the t-test, okay, one by one. All right, so I don't go through it in details because suppose we already go through the example one, the similar case, okay, test for the x1 significant and test for the x2 significant. Okay, so this time we have to test individually, okay, if we want to test whether x1 is significant in the regression model or not, just test on the beta 1, okay, equal to 0 or not equal to 0. Okay, and so on and so forth for the x2 and x3. We test it one by one. So let me just show you or highlight. Test for x1 significant. Okay, test beta 1 equal to 0, h1 beta 1 not equal to 0. Test for x2 significant. Beta 2 equal to 0, beta 2 not equal to 0. And test for x3 significant. Beta 3 equal to 0 and beta 3 not equal to 0. So in the final exam, again, I will hide the t-test statistics, hide the p-value and other the remaining parts. So you can only use the given informations to find the t-test statistics, okay, and use the critical value approach, okay, to do so. So okay, so here we have to make use of the coefficients and the standard error, these two informations to find the t-test statistics, isn't it? Okay, so how can we find the t-test statistics? Okay, let me highlight this one. Okay, so you have to memorize the test statistics, the formula by yourself. So here, okay, this is the test statistics. t-test, the test statistics, okay, the formula. So is t equal to b1, the sample slope minus the beta 1, the population slope over the SB1. S stand for SB1 is the standard error of the B1. Okay, so actually these two values are given in the questions. Okay, so in the Excel output, so B1, this is the B1, isn't it? Let me just write down. Coefficients, okay, coefficients of X1, so this is the B1, the sample slope. Coefficients of X2, okay, so just like that is the B2, the sample slope or sample coefficients of the X2, okay, and coefficients of X3, that is this one, we highlight below. Yeah. This is B3. So therefore, give the question, the part A asks for the least square, find the least square regression line. Okay, so we can just form the least square regression line by using the last table, the information that in the Excel output. So this is the B0, the intercept. Let me also write down. Y hat, you just write down. Y hat, okay, this is the Y hat for the sample regression line. Okay, Y hat is equal to B0, 7.945 plus, this is the B1, 1.148, okay, times the X1. Don't forget to times X1, and then plus 0.197 times the X2, and then plus the 2.28 times the X3. Don't forget, yeah, to write down the times, okay? Don't just write down the numbers. So this is the sample regression line. Okay, the least square line is the sample regression line. Based on the Chanty programmer, the data to do so, sample regression line. Okay, so all right. So here the test statistics. Okay, the B1 and the SB1, we can obtain it from the Excel output. Oh, yeah. And then minus the beta 1. Okay, so actually it's minus 0. The beta 1, that is the substitutes the H0 value now is equal to 0. So here I also talk about it in class. Okay, it's minus 0. Usually I will, yeah, we can, okay, minus 0. Okay, and then the next step is the rejection region. Okay, so remember first steps. Oh, yeah. Okay, the mouse is not so good. Okay, it's not smooth. Okay, 1 and then 2. Second step, calculate the test statistics, 3.8 something. Okay, and then the third step is the rejection region. So remember this time, okay, so the degree of freedom. Okay, now first of all, I just teach you. Going back to the t-test, okay, so we just draw the symmetric curve. And then indicate this is the t curve, and then the mean is equal to 0. So the rejection region, remember we should look at H1, the sign. Now H1 is the unequal sign, so the rejection region should be two-sided. So we cut the two straight lines on the diagram, one on the left-hand side on the T curve, one on the left-hand side and one on the right-hand side. And shade the area. Each side will be the rejection region. And so each side is alpha or alpha over 2. So remember, this time is alpha over 2 because it is two-sided. Give one side just equal to alpha over 2. Now is alpha is 0.05, so divided by 2 is 0.025. Okay, wait a minute. 0.025. 0.25. Not enough space. Okay, so here also 0.025. How about the color point? They are the CV, critical values. So, okay. I use the blue color. No, purple color. So because this is the t test, so the t curve, we check the t table, t 0.025. And be careful, the degree of freedom. Okay, in the regression, this is the n minus p minus 1, not the n minus 1 anymore. N minus p minus 1. So actually, we can just copy, from the value in the denominator in the f. Maybe I'll use other color or no, just take this one. Yeah, it's this one. So it's 16. Okay, so you can see here is 16, the degree of freedom. And then we can check from the t table, we can obtain the two, the t values. So one is the 2.120, and another one is negative 2.12. Okay, and then the last step, just locate the test statistics, see whether it lies on the rejection regions or not. So now here it lies on the rejection region, so we should reject the H0. And so therefore X1 is significant in the regression model. Okay, and so on and so forth for the test for the X2 significant and the X3 significant. So as I mentioned, going back to the p-value or the Excel output, we can quickly go through it. Okay, so yeah. So by the p-value, okay, maybe I just type, okay, by p-value of the X1, okay, by the p-value of X1 and X2, okay, not by, okay, both p-value of X1 and X2 less than alpha equal to 0.05, so they are significant in the regression model. However, but p-value of X3, which is the 0.268, okay, which is larger than alpha equal to 0.05. So X3 is not significant. Okay, in the regression model, regression model. Okay, let me also highlight these two results. Okay, so therefore, okay, going back to the Word file, in the example, I will tell you, we will ignore the X3 data and we run the regression analysis in the Excel by just using X1, X2, and Y. So after rerunning the regression model, then here is the the fitted or the regression model that is good to show X1 and X2 is related to variable Y, and the whole model is significant, and the individual, the X1, X2 is also significant in the regression model. All right, so that is the presentation of using the Excel to run the regression analysis. Okay, using the example 2 in our chapter 4 part 2. Okay, yeah, this example to do so. So yeah, again, I will design some assignment, okay, which includes some Excel parts. Okay, so maybe let you to run the regression output or regression analysis to do some questions. Okay, thank you for watching. And yeah, add oil, okay, for the for the final exam. Okay, so thank you very much. Thank you for watching. See you. Bye bye.